Hello everyone. In this video, I am going to explain you what is Huffman coding. Huffman coding is a lossless data compression algorithm which reduces the size of a message. Let us assume we have a sequence of characters. Let us assume it is input message. We need to transfer from one end to another end, that is source to destination, or we need to reduce the size of a message. Let us assume a sequence of characters 5A and double B and C. So this is the message I need to compress. So now in computer it will accept only ASCII values. The total character, each and every character will be assigned with the ASCII value, and that value will be stored in the form of a binary values. For example, A is having the ASCII value of 65, and when it is converted to binary, the value is 0, 1, 1, 5 and 1. Okay, and here B, the ASCII value for B is 66, which is equal to 0, 1, 4 zeros and 1 0. And similarly for C, the ASCII value is 67, which is equal to the binary value 0, 1, 0 0 0 0 and double 1. So if you observe here, all the ASCII values in binary format, each and every character is having 8 bits. So 8 bits. So now how many characters are there in this message? 1, 2, 3, 4, 5, 6, 7, 8. So total 8 characters are there. So 8 into 8 bits, which is equal to 64 bits. I need to transfer total 64 bits, which needs to be compressed, which needs to be reduced. Let us apply Huffman code here. In this Huffman code, the rule is the first we have to identify two list values. We need to identify two list values, two least frequency values. And second step is we have to add, that is sum the two values and which will form an internal node. This process should be repeated until there exists only single node, that is only one node should be there in the tree. These steps we have to repeat until we create a total Huffman tree. Let us take one example here. The same example I am taking. Total how many characters? A and B, B and C. Total 8 characters are there. Let us write the character and associated frequency. So this is C. How many, what is the frequency of A? 1, 2, 3, 4, 5. So 5 times it is occurring in the message. So the frequency of A will be 5. And for B, the total value will be 2. And for C, the total value will be 1. These are the frequency of the character, and this is the characters. Okay. So now we have to, the first step is we need to identify the first two list values. So B and C are having the list values. So these two values should be added. The second step is we have to add these two values, 2 plus 1, which is equal to 3. This will form an internal node. Now let us draw a Huffman tree. So the value is 3. This will have left child. Similarly, right child. So right child, the value will be B. Value frequency is 2 and C 1. There are no left and right sub child nodes, so I am marking it as null. This is one subtree. We have drawn one subtree. So now we have to check whether there are only one node left out in the table or still we have some nodes. So now character frequency of each character. So left out values of internal node value, which is equal to 3. Value of A is 5. So now only 2 nodes are there in the table. So we need to add these 2 values. So 3 plus 5, which is equal to 8. Now 8 will become an internal node. Let us draw an internal node. 8. So now what is the least value here? So we have added 3 plus 5. So now 3 is an internal node. So 3, right child will be A. Since we are adding A and internal node, the value of A is 5 and it doesn't have it, right child and left child, so it will be null. So now 3 is the internal node which is having 2 child nodes, left child node, right child node. So it has C, frequency is 1, and here B, frequency is 2, and no left and right child, so it will be marked as null. This is the final Huffman tree. Now we have to encode the values for all the characters A, B and C. So how can we encode? The rule is when we are traversing towards left side, the value should be 0, and when we are traversing towards right side, it should be marked as 1. So now if I want to find the value of C, I have to start from the root node. So left side we are traversing, so it should be marked as 0, and here left side, so it will be 0. So the value of C will be from root node to leaf node. What are the values we have got? 0, 0. So the value will be 0, 0. This is the binary value for C. Similarly, we have to find out the value for B. So from root node to child node, we have leaf node, we have to find out the values. So left side 0, right side we are traversing, so the value will be 1. So 0, 1 will be the value, and for A the value is 1. So these are the binary values finally coded for each and every character. For A it is 1, B 0, 1, C it is 0, 0. Now let us find the total number of bits we need to transfer from sender to receiver, or the compressor data size. So what is the size here? What is the frequency here? A frequency is 5, frequency of B is 2, frequency of C is 1. So now A value, how many binary values we have encoded? 1. So 1 into frequency, which is equal to 5. For B, the total number of binary values encoded is 2. So 2 into 2, it will be equal to 4. And here the frequency is 1 into total binary values are 2. So which is equal to 2. So 5 plus 4 plus 2, which is equal to 11. Initially, we have got totally 64 bits. The original message, it has 64 bits. That is ASCII value into number of characters, which is equal to 64 bits. Now we have reduced the total size into 11 bits. But there is no loss of data. This is the main advantage of using Huffman code. There is no loss of data. We are transferring the same message or compressing the same message, but there is no loss of data, only the reduction of data. We are reducing the size of the data. Reducing the size, and there is no loss of data. This is the way to construct Huffman tree, and this is the way to calculate total number of bits to transmit. And let us see what are the applications of Huffman Tree. Applications in real time for data compression. This may be text or audio and video. This is applicable for audio, video and image also. Video, all these we are compressing the data, just reducing the size of your data, so that the advantage of compressing data is that the data transfer will be high. Data transfer will be, there won't be any latency, less latency. And multimedia compression, zip file compression, we can go for zip file. So when we are sending a mail, when you are sending a mail, when there is attachment size is very large. Larger attachments, we can compress the data. We can compress the data so that the data transfer will be very fast. This is one of the application, and overall we can say that advantage is faster data transmission. Faster data transmission saves storage. And the third point is reduces file size.